Hello and welcome back to Mr. Haas's math help videos. Thanks for coming back. So what we've got today is lesson 23, coordinate planes. Coordinate planes are those planes that, well, they're kind of like two number lines that meet at their 0 points. In other words, 0, 0 is right here, the origin. Let's see, so I'm just going to create one here real quick. 1, 2, 3, 4, 5, 6, 7. I'll go as far as 8. What the heck? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7, 8. Now, you know that this is the x-axis, and this is the y-axis. Over here, these guys are plus, and over here we've got minus x's. Up here we have plus y's, and down here are minus y's. So, and you're going to end up always having ordered pairs. Well, let's find the difference between 2 points. And really, that's nothing more than just counting your way there. Unless, of course, you're going on a diagonal. But for argument's sake, we're just going to do the straight line. So let's set up one here. Let's go -1, -2, -3, -4, and up to 6. So 1, 2, 3, 4. We're going to go 1, 2, 3, 4, 5, 6, over and meet. And this is going to be, I'm going to label it point A. And the ordered pair for this, remember you do the x number first because x comes first in the alphabet, -4, and it's a +6, okay, because we went up above the x-axis. Okay, so there's our first point. B, let's put in at 2, 6, which would be right about here. And that is point B. And the ordered pair for that one, again, is +2x and 6y. Okay, great. And let's set up -1, -2 for the third point in this triangle. So there's point C, and again it's -1. We went over 1 on the negative side of x, and down 2 into the -2 for the y. Sorry, I got a little collidey there. Okay, so we can make our triangle now, right? By connecting the dots, the lines, whatever. Okay, so now, what's the distance from A to B? All right, well, easiest way you can do it is to count from here. We go over 1, 2, 3, 4 to get us back to our origin, and then 5, 6. So it would be 6. You just count your way over there. Another way you can look at it is we went from -4 to 2. So this would be to get to 0 right here. It is 4 going that way. And the rest of the way is 2. Distance from your point to the origin or to the y-axis. So 4 plus 2 is our 6. So that's all you got to do. That's not a hard one at all. Okay, so next, finding the missing vertex. Well, a vertex, that's another name, a fancy math name for a corner point. Okay, so we're going to find the missing vertex. Okay, that's a corner point. All right, so got to make up my coordinate plane. 1, 2, 3, 4, 5, 6, 7, 8, and there's no magic to the number 8. Unless you are Chinese, in which case they think the number 8's great, and that's a lucky number. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And no, I am not Chinese. Okay, so let's take a look at plotting our points. So point A. Point A, let's put in at 4, 7. 1, 2, 3, 4. Okay, and we're going to go up 1, 2, 3, 4, 5, 6, 7 over to where those two meet. I'm going to put my dot, and that is letter A, and it is at the point +4, +7, and that's point A. Point B, let's put at -1, 7, so that's right in here. So that is B, and it's at -1 because it's to the left of the y-axis, and then 7. Okay, so that's our B. So far we've got that part of our shape. And point C, let's go to -1, 1, 2, -2. So here is C, -1, -2. That's our coordinates for point C. And if we connect them, looks like that. Okay? Good. Now, two ways you can do this. One, you can kind of just go straight down, since it looks, guess what? It looks like a rectangle. So we're going to go down right on through here, and you can go a little bit beyond. And you can come across like this, and where the 2 points meet, or the 2 lines meet, that's where your point's at. Okay, and that would be our point D. Well, another way of looking at it is this. You went over to get point A, you got to go over 1, 2, 3, 4. So we know that point D is going to have a x coordinate of 4. And what's its y coordinate got to be? Well, it's down as low as C's, and we had a -2 for that. So there's our y coordinate. So our answer for that is 4, +4, and -2. That's the coordinates. And you'll notice, look here, this one's got 4, that one's got -2. Look at here, the x, same x, here the same y, they're the same y. So they kind of like, if you've got a nice rectangle, they hold the same point, or if you've got something like a right triangle or so. So let's talk a little bit while we're at this about finding perimeter. Perimeter is nothing more than going around the shape. It's like you're building a fence or a wall or something, okay? So, perimeter, distance around. Okay, distance around the shape. You add them up. Add the distances. All right, well, what's the distance between A and B? Well, we have 4 this way and 1 from there. The distance from -1 to the 0, the y-axis, is 1. So we have a 5. What's the distance from B to C? Well, let's see, this is at point 7, so to get back down to here, we got to go 7. And to get down to -2, we got to go 2 more, so that's 9. So +9. Over to our point D, we have to go 1, and then another 4, and it's 5. Well, look at that. When you got yourself a rectangle, you're going to have the same. We're going to have the same distance, and guess what the last one's got to be? It's going to be a 9. So if we go from D to A, we got to go 2 to get to our x-axis, and then we got to go another 7 to get up to A. So that's 9. All right, so well, if we add these all up, I have 28. And that is the perimeter. Area is really easy. We already know these distances, right? So we take one pair of distances, and it's 5 times 9, and that's 40. So that's our area, in case you need to know that. All right, so there you go. All right, let's take a look at, sorry about the bump there. Let's take a look at find the area of shapes on a coordinate plane. What if we got a compound shape? Okay, so this is a compound shape. What a compound shape is, we talked about that in the last video a little bit. Compound means you've got more than one thing and you're mixing it up together, okay? So when you've got a compound shape and you're trying to find the areas, you're gonna need to know more than one formula because you're gonna be doing more than one shape. So let's take a look here what we've got. Let's set up a coordinate plane real quick. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's put in something. Let's go to 7 here. 1, 2, 3, 4, 5, 6, 7. And I'm going to go up to, let's see, let's go up to 7 again. 1, 2, 3, 4, 5, 6, 7. Okay, and where they meet, I'm going to put 1 point. Okay, and so that's going to be one line of our shape. And let's go 7 over. Okay, then we're going to, so this distance here is 7. This distance is 7, we know that, right? Let's go another 6. So 1, 2, 3, 4, 5, 6. Okay, and I'm going to go over and find where 6 meets, right about in there. Okay, and let's go up 3 from the origin. 1, 2, 3. Okay, and let's go over 4. 1, 2, 3, 4. Up and where those guys meet. Okay, and this is going to be our shape. This distance over here is 6, and this one, well, that's all I really need to give you. Because you know if this is 7, and you can just look at this. This distance here is 4, right? This distance is 3. If this is 1, 2, 3 up this way, you can get that distance. This is the only one that's going to give you a little bit of trouble here, but you really don't need to know it. And the distance from here, 1, 2, 3, 4, well, that's 4 as well. Okay, so what we've got basically, and you can cut this up 2 different ways. We've got ourselves a triangle here, right? A right angle triangle. So we have 1/2 times the base. Let's use 4 as our base, times the height, and there's our 6. Okay, so that's this guy here, right? And let's see, half of 4 is 2. 2 times 6 is 12. So my triangle is 12. Now, you can either, 1, draw a line down this way and cut this shape up into 2 rectangles, or go across this way. I'm going to do that. I've got a nice 3x3 rectangle, so I'm going to label this rectangle number 1, okay? That's shape number 1. This is shape number 2. I'm going to put a 2 here just to let me know that's number 2. Number 1, and this will be shape number 3. I circle them so that I know that I'm not talking about distances. Just helps me get the shapes down. All right, so this one, look, it's 3x3. Easy. 3 times 3 equals 9. Okay, so far I've got a 12 and a 9, 21 so far. Shape 3, well, that's not going to be hard either. This side is 4. That length is 7. So I have 4 times 7. That equals 28. What did I say I had? I had 21. These guys together is 21. Plus the 28, well, that's 49. So that is the area of this funky shape here, this compound shape. Okay? That's how you do those. Now, I want you to know the names of some of the triangles, okay? Because we've been talking about triangles, and I've kind of mentioned a few of them. So these are names of triangles. Okay, good. All right, so first one we're going to talk about is a right triangle. It has a little box in the corner. What this little box means is this is a right angle. R-I-G-H-T, angle. A right angle is 90 degrees. Okay? That means these two are at 90 degrees. There's a lot of cool stuff you can do with right angle triangles. And again, I'll write the name for this one. This is our right triangle. R-I-G-H-T, triangle. And we call it that because it's got that right angle in it. Okay. Equilateral. Equilateral has a neat word in it. Equal. Right? Equilateral. All right. Equilateral triangle is kind of a special one because each one of these sides, I'm going to put just a number in here, 9. Each side is the same length. Same length. And even crazier, each one of these angles in the corners here, they are all the same. And that's why I put these little lines in this arc. That means that they're all the same. If I was to draw in the angle marks in here, I would want to draw this one with 1 and this one with 2. And they could be the same, but in this case, I didn't draw them that way. So that is not a special type of right triangle that I'll talk about in just a minute. Up here then is the isosceles. Okay, isosceles is just a little bit different from the triangle, the equilateral triangle, in that 2 of the sides are the same. 2 sides. Okay, 2 sides are the same. That's an that's an isosceles, and it's spelled I-S-O-S-C-E-L-E-S. Isosceles. 2 of them that are the same. These angles will be the same, right? Because they're the angles opposite the 2 sides, so they've got to be the same. Okay, and the last one I'm going to talk about today is, I'll do it down here, an isosceles right. Okay, he is kind of like a special version of the right angle, right triangle. These angles are going to be the same because these sides are going to be the same. And of course, we've got that 90 degrees right here, saying that these are at a 90 degree. Did you know that all triangles have to have 180 degrees? All triangles are 180 degrees. If you add up all the angles, that equals 180. Well, if we wanted to know what these are, this is very easy now here, because these have to be the same, these 2 angles. And if we take away 90 minus 90, that leaves us with 90 degrees. And we have to divide that by 2. That means that each one of those angles is 45 degrees. So it's a very special one. This is a right isosceles. Right isosceles triangle. All right. Hope you enjoyed the video. See you in class. Oh, wait. One last thing. I'm sorry I go crazy here. I'll leave it. We'll talk about it in class. See ya. Bye.